main objective of the course is to get you all an hands-on experience of modeling this cabin interior monument in PATRAN, or just to give you a brief overview or a brief idea about how we model things in PATRAN and carry out structural analysis of these cabin interior monuments. And here, I think there are few students in the audience wondering why we are using finite element analysis, why not an other method. Basically, the reason is the finite element analysis is a method by which you can analyze a structure or a complex structure and then produce the result, or you can generate a result for the structural analysis that you have done, and you can go further and produce a stress report based on the results that you have generated. To tell what is FEA here is just a numerical method which is used to analyze the structure, and in simple terms we are just breaking down the complex geometry down into finite number of small elements, and then applying and then seeing applying loads to the structure, and then seeing what all the stress and strains and deflections those elements generate. It's one of the methods that evolved in the late 50s to solve complex structural problems. Basically, any engineering problem can be solved by analytical method, numerical method, and then an experimental or a test method. So analytical method is just a classic approach where you define a governing differential equation for a problem, and then you go ahead and solve that governing differential equation. So one of the thing in using analytical method is, if you have got a beam problem or a simple problem, you can use an analytical method. Whereas if you have, as I said before, if you have got a complex galley structure or a wing structure, or for example fuselage structure, you can't use the analysis or an analytical method and do everything by hand calculation. It's not such simple, and it's going to it's practically not possible. So you have to use the finite element method, or FEM, which is a numerical method, and then it saves your computing time. It basically you can model the entire structure in the FEM software like PATRAN, and then you can apply the loads that the structure will be subjected to, and then you can decide stress or strain results. This numerical method is nothing but a mathematical, it's a mathematical representation of the structure. It can be used to analyze real life complicated problems, and there are different types of numerical methods currently used in the aircraft industry. And for the aircraft structures, we use the finite element method. And for there is another method called as boundary element method, which is used for acoustics and NVH problems, noise, vibration, and harness problem. And if you want to do some flow analysis, they use a computational fluid dynamics method, which is a finite volume method they use to analyze all the flow problems. And also a finite difference method. This will be using an explicit solver like LS Dyna and Abacus to solve all the dynamic stuffs and the crash stuffs. So in real life, if you see, these structures are continuous, and these if by saying continuous, there is no physical gap between two consecutive particles. If you take any structure, in a sense, as per the material science, all these objects are made up of small particles. They are made up of, again, particles of molecules and atoms which are bonded together by force of attraction. So in the real life thing, this continuous approach is very difficult, and it's practically not possible to solve such a complex structure. So we are going to use this simplify the problem by discretizing the structure and dividing into a lot of smaller finite elements. And in simple words, these nodes work like atoms with gap in between filled by the entity called as element. So the calculations are made at nodes and the results are interpolated for elements. So this is my brief overview about FEA. There are a lot of, so if anyone of you is or very interested to know more about or study more about FEA and then go deep into the analysis procedures, then you can use different source available to you, and there are a lot of sources from MIT, IITs, and which are commercially available in platforms like YouTube. There are a lot of lectures or open courseware. You can go ahead and see that and try to learn that more about FEA. And again, few people might have in the mind, again, why we are using this for the cabin interior business, because this is it's the using an FEA tool will simplify our job, basically, because the cabin interiors, the galleys or monuments, they're all indeterminate structures. They've got a lot of support, or for example, a typical galley will have 5 to 6 lower attachment. So the structure is totally indeterminate. Here, again, just to have just my side is indeterminate. I think indeterminate structures. I think people here, the audience will be or aware what is the difference between determinate and indeterminate structures. Indeterminate structure is where the number of support reactions are more than the equations of available equations of equilibrium. So when you are solving for an indeterminate structure, it's going to take a lot of time when you use a classical analysis method to solve, and to use the equation of compatibility and those things, which is not practically possible for a complex structure like a galley or a seat. So we are using the finite element tool to make our job easier. And again, when you are performing the structural analysis of an interior monument, sometimes the customer comes back and asks you where you are getting maximum deformation and which particular compartment is suffering from max deflection. So where you can actually, by using tools like PATRAN, you can actually visualize, and then you will be able to give an exact answer to your customer. And one of the key thing in the aircraft interior industry is testing. So I have witnessed several structural tests as an AP1020 test approver and test witness for Airbus. There are companies which spend millions of dollars and pounds for setting up a test facility and coming up, and because they want their product to get certified, so they have to show to the customer actually that their product is good enough to withstand all the loads which the product will be subjected to as per the CS25 requirement. So they take off. So once you build the galley and they put the entire galley into the test rig and then apply the loads, then again we monitor what load reactions you are going to get at the upper attachment and lower attachment, and then you correlate the test results with FE, and then you tell that if the test results are within an acceptable margins, then you declare, okay, the test that you have carried out is valid and that can be used for certification. Suppose you are testing a product, and again that product is you get some results in the FE, and if you are finding a huge deflection in the actual test, and that actually puzzles the customer. See, your FE is telling that you are getting an X number as deflection, and whereas your test is showing a huge deflection, or your FE is telling you are getting such amount of load or such amount of you are seeing a little stress only in that area, whereas that particular area has seen high stress and it has failed in the test. So when things occur like that, normally the customer will ask you to first investigate your FE model to see what's going on there. So I'll tell you one of the key thing in FE modeling is you have to assume things correctly, and you have to model and you have to represent the things correctly, because in interior business is so rigid that airlines, they want their product to be tested before they give certification. So when a manufacturer of this interior component goes into the testing stage, they want full confidence in their people to declare that their product will pass the testing. Suppose you work as a senior stress engineer in one of the major aircraft interior industry, and you have generated the stress results for a particular galley or a monument, and when that product is going to go for testing, and all the eyes will be on you because you are the one who declared using your stress analysis that the product will be passing without any failure in the test. So everyone will be looking at you. So they'll be waiting for, they'll be waiting the test to be complete. And once the test complete, and there is a phase where there will be a correlation done between the test results and the FE results that you have produced. So it's one of the very important thing to get your FE right and make all your assumptions, and everything should be very clear in the beginning, and you should produce an exact result. And if you are seeing anything, you should be able to predict if something is going to fail in the test upfront. It's not that going to the test and failing and wasting billions of dollars. So you should be very, very clear in your approach you are taking and the results that you are seeing. So FE is very important, and it plays a very, very key role in the aircraft interiors industry. So I've added a slide to tell the general FE analysis procedure here is, I think everyone in the audience will be aware of this. If you have used PATRAN or any other FE software ANSYS, it's always the FE steps are generalized or subdivided into 3 general categories. One is pre-processing, which is like bringing in the geometry and then extracting the mid surface and then meshing the geometry and assigning the material properties. and defining the loads and boundary conditions, and then populate the finite element model with appropriate material properties and stiffnesses and those things, and so that your model is more or less closely matching with the real scenario. And because the FE itself is just a numerical approach, and it depends on the assumptions that we make, and we should be very clear in what we are doing and what properties we are giving to the elements, and what are all the assumptions that we are making on the boundary conditions. So we should be very, very clear. So the second step is solving that, and this PATRAN BDF can be solved using NASTRAN solver, and the results format or XDB and OP2. And again, post-processing is seeing the results that you're willing to see. These results can be viewed graphically in PATRAN by importing XDB or OP2 file, and you'll be able to see where max deflection is, where is the location of max stress and everything. So the main purpose of this course is to get you all used to all these 3 steps, and how we are going to do analysis of an interior galley or a monument in PATRAN. And then, in the actual course, I'll be able to tell detailedly about all these 3 steps, and we are going to go through all the 3 steps in much detail, and there will be hands-on practical problems that will be given to you, try from your end. Sticking to the objective of this presentation or this course is why we need PATRAN and NASTRAN, because it's commercially available and they are widely used in aerospace industry across globe. Most of the interior companies, 99% of the interior companies, they use PATRAN, and some of them they use FEMAP, but again, FEMAP is used only for the pre-processing, which is for meshing. It's like hypermesh, but when it comes to solving and post-processing, definitely PATRAN is used. And again, when you look at the stress reports or the stress dossiers that which the interior companies produce, they all include pictures and deflection plots and stress plots from PATRAN. And here I just added a picture for the NASTRAN. It's a solver for displacements, and you can compute strains and stresses. And one of the key advantage of using PATRAN is you can model the composites using PComp properties, and you can use a composite laminate modeler option in PATRAN, which is available commercially now, which is included in the package, by which you can see how we have modeled each and every lamina, and also you can tailor the stacking sequence, like in which way you want to stack up the sequence, and you can physically change the ribbon direction of the core and other things. So there are several good options which are included in PATRAN and NASTRAN, and they have got good solving ability for composites. And again, in terms of failure theories, you are in NASTRAN, you are given so many options to choose which failure theory you want to use to determine the failure stresses and strains for composites, like Sahil, Saihu, and all other options are available, and you can get familiarized with that, and then you can compute the results whichever you are expecting to go, or whichever approach you are expecting to take. Yeah, and one of the key advantage of PATRAN is model is to manage the model in groups. If you've got a big model, you can divide that into subgroups and into sub collectors and other groups, easy to manage. You can also, if you get a raw FEM, you can just go and there is an inbuilt option to group the elements according to the properties, according to the PCOMs, and so many different options. So you can basically use that to keep your model organized, and just for cross verification and checking, it is lot better, and it's very user friendly. Yeah, and this I've just included the finite element model and the deflection that we have predicted for one of the galleys. In this galley, this particular slide just shows an overview how we have applied how we have built the finite element model using taking into account all structural panels of a galley, and then taking into consideration of all compartment loads and trolley loads and all other things. And this I'll be telling about much about how to model and how we are going to represent different loads in the actual course, but this is just a overview session. Opportunities, few of you might already have a doubt in mind that what will be the advantage of doing this course, because this particular course will give you a good idea about aircraft interior components, and also how to carry out how to model them in PATRAN, and how to, of course, run the analysis of those interior galley monument. So by doing that, you will have a broad understanding about aircraft interiors and how to carry out structural analysis. So this will actually enhance your knowledge, and if you are interested, or if it inspires you, and this course will help you to gain job, or it will help you to clear the interview, or it will help you to decide in which career path which career path you want to choose, or it will I believe that it will definitely inspire you to take a job to become a structural analysis engineer in the aircraft interior industry. So in terms of the opportunities you get, you will definitely get a chance working with some of the aerospace OEM majors. And then once you get into an industry like a graduate stress engineer, then again, depending upon the industry situation, there will be always there are plenty of opportunities to gain career growth from a junior position to a senior level roles. So and the other opportunity this course will create for you is good understanding about the aircraft interior industry, because this particular business, I know there are several aviation experts, and I've back in India, I've got several lot of friends who are working in different aerospace companies. And from what I heard from the people is there are several experts in different field, but this still there is a bit of gap in the in India, or it's there are hardly few people who have stepped into aircraft interior industry. It's still there are a lot of potential for the growth in India for big companies or big OEMs to enter into this particular market, and that will actually generate a lot of jobs for youngsters. and basically there is a huge huge opportunity in this particular sector. Yeah, once you gain a good understanding and you gain good experience working in the structural as a structural engineering or a structural engineer level, and basically you can there are two, either you can go into management or become a stress manager and things like that, or basically you can, if you're interested staying in the technical side, you can become a stress approver, whereby all the major stress reports are, you'll be able to approve your product based on the analysis done and basing on the testing done. And also you also have a fair chance of becoming a CVE, compliance verification engineer, or a DOA, independent monitoring. Is, as I mentioned in one of the slide before, every product which is going out of the industry should get a certification. So the role of compliance verification engineer is he verifies whether that particular product meets all the required compliances laid out by CS25 or 14 CFR 25. So it's such a big responsibility, or it's just CVEs are one step above stress approvers and test witnesses, and they became complete. They actually become complete. They take the complete responsibility of a particular or certifying a particular product. So CV is such a big responsibility on your shoulders. When your signature, or when you sign the document, that means that you are certifying that product. That means it meets all the airworthiness requirements, so that it can go and it can be installed in an airplane. So you have every chance to become a CVE, depending upon the learning and depending upon the interest that you show, and the future is really bright.